about this bad boy right here? How do you suppose we deal with that? Perimeter is add the sides. Well, a circle is one big side that really never ends. It comes back on itself and it just goes on and on. So we have special words for perimeter and area. We call the perimeter the circumference. circumference. We call it the circumference. And we call the area. Area is still area. But for a circle, the perimeter is actually the circumference. The formula for the circumference is this. And now you've just dropped over. What am I doing? This is the Greek letter pi. Pi is approximately, wavy equal sign, 3.14. If you want to get more specific, it's approximately 3.141592653589799, and then it just keeps going and going and going. Pi never ends, and it never starts to repeat itself. 3.14 is a common approximation that you'll see for pi, but it is not going to give you an exact answer. Not exact because it's not exactly 3.14. It's all that. So March 14th, that's why that's called Pi Day, 3/14. It's not eating pie, which you might do on Pi Day, but it's about this pi, the mathematical pi. So the circumference, the distance around the circle, equals pi times the diameter. Well, what's a diameter? That's another new word. A diameter, now I've drawn a Pokeball. The diameter is the length of the circle at its biggest point. So not that. That would not be a diameter. Halfway down. Splits it into two equal parts. This would also be a diameter. Two equal parts. These two diameters cross each other. That's 4 equal parts. But anything that goes from one end goes through the center of the circle, that's a diameter. Full length. We have a special word for half of a full length as well. Very important word when it comes to area. We use the letter R for radius. R equals the radius. And what is a radius? It's half of a diameter. A diameter divided by 2 will give you the radius. And the area of a circle is pi times the radius squared. Since 2 radiuses, the plural, by the way, is radii, since 2 radii make up a diameter, another formula you'll see for circumference sometimes is 2 pi r, because 2 times the radius, 2 radii, make up a diameter. So this is the same as pi times the diameter. So now here we are with two formulas, one for circumference of a circle, one for area of a circle. And all you need to solve either of them is a radius measure. If you have the radius measure, you can find an approximation by using 3.14 for pi, or you can just keep pi pi and get an exact answer, right? Okay, so we have a circle. The circle has a radius of 6 meters. We're going to find the circumference in terms of pi. In terms of pi means we want an exact answer. Do not replace pi with 3.14. So the circumference is going to be 2 times pi times r. So 6. And 2 times 6 is 12. So we have 12 times pi. 12 pi right next to each other means times. That makes sense. If 6 is the radius, then the whole diameter would be 12. Pi times the diameter, 12 times pi. Since it's just distance around, not stuff inside, it's still going to be meters, not meters squared. Meters squared, that's going to be for area when we multiply meters times meters. So 12 pi meters would be the exact answer here. Now let's also find an approximation. For an approximation, we just continue. And now instead of pi, we're going to replace it with its approximation, 3.14. And we multiply 3.14 times 12. That's why we've waited until now, because we need to know how to multiply decimals. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. Move over to under the 1. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. Add 8, 6, 7, 3, 2 places past the decimal. Whoops. So 37.68 meters would be an approximation, not exact. Exact would be 12 pi, but 37.68 meters would be the distance around this circle, the perimeter, but its special word, the circumference, because it's a circle, makes it special. What do you think? You're some type of circle? Okay, let's do it again. This time our circle is 5.2 yards for a radius. Let's find an exact circumference. Let's then do an approximation. If 5.2 is the radius, that means we have 2 times pi times 5.2. 2 times 5.2 is 10.4. So 10.4 pi is the circumference, and that's in yards. How would we get an approximation? Well, we would replace pi with 3.14 and then multiply 10.4 times 3.14. 4 times 4 is 16, carry the 1. 4 times 0 is 0, plus 1 is 1. 4 times 1 is 4, and then 1 times everything. 4, 0, 1. And 3 times everything. 3 times 4 is 12, carry the 1. 3 times 0 is 0, plus 1 is 1. 3 times 1 is 3. I forgot to move over. 3 times everything. 3 times 4 is 12. Carry the 1. 3 times 0 is 0. Plus 1 is 1. 3 times 1 is 3. We add 6, 5, 6, 2, 3. And 1, 2, 3 decimals, places after the decimal, makes this 32.656 yards. Okay. You might be thinking, where's the joke? You said we were going to divide decimals. We know how to do this. This is 5 remainder 3. 5 goes into 28 5 times, multiply around the corner. R3, right? Well, before now, yes. Unfortunately, now we know decimals. And the problem does not end until it ends. When we get to a situation where we do not have a 0 remainder, and we do not have anything else to bring down, now that we know that 28 is the same as 28.0, we must put a 0.0, bring down that 0, and then continue until we do get a true 0 remainder. 5 goes into 36 times, and that is evenly 6 times 5 is 30. No remainder. The answer is not 56, though. When we put the decimal point in, wherever that is directly above, it goes in there. So this is 5.6. And that makes sense. 5 remainder 3. There were 3 left over, and now we have some decimal, some part left over. Okay, now something that actually looks like dividing decimals, because we see a decimal from the start. The number one rule in dividing, when we set this up, when we go divided by, on the outside, is there a decimal? If not, we're good to go. Bring the point that's in there up, directly up, and divide like normal. 4 goes into 0 0 times. 4 goes into 0 0 times. 4 goes into 6 once. 1 times 4 is 4. We have a remainder 2, but we don't say remainder 2. We put in a 0. We bring it down. Why didn't we go 0.0? Well, this time the point was already there for us. We can add our zeros without problem. 4 goes into 20 5 times evenly. 5 times 4 is 20. Remainder 0. 0.015 or 0.015. That first 0 to the left is not necessary in your answer if you choose not to have it. Let's do 7.088 divided by 16. Well, 7.088 divided by 16. Ask ourselves the most important question. Is there a decimal on the outside? Nope. So we're good to go. Bring that decimal point straight up. 16 goes into 70 times. 16 goes into 70. Does it go in 5 times? 16 times 5, 0, carry the 3. That's 80. That's too much. How about 16 times 4? 4 times 6 is 24. Carry the 2, 64. Yeah, that fits. So that was 16 times 4 to get 64. Subtract, that's 6. Bring down the 8. 16 goes into 68. 5 times is too much, so it goes in 4 times. 4 times 16 is 64. Subtract, bring down the 8. So we have 48. And I believe 16 times 3, yep, happens to be 48. So we didn't have to put any zeros in. We ended up with a true remainder of 0, 0.443. So what if we're not all good? What if you walked up to a problem and you asked it who it was and it said, not Saul Goodman? That joke was a deep cut. It's okay. Let's say we had 0.143 divided by 0.13. The most important question that we ask first, is there a decimal on the outside? And this time the answer is yes. It is not all good. We cannot just divide. We cannot proceed with moving the decimal point into the answer. We have to get rid of the decimal on the outside, and we can do that by moving it to the right a certain number of spaces, however many it takes. 1, 2, we'll get rid of it, turn it into the number 13. 1, 2 there has to also be 1, 2 here. So instead of 0.143, we actually have 14.3. Now everything is good. Now we can move the decimal point up and continue with our division. 13 goes into 14 one time. 1 times 13 is 13. Subtract, we get 1. Bring down the 3. 13 goes into 13 one time. Evenly, no remainder, nothing else to bring down. 1.1 is the answer. And we only get 1.1 if we take care of getting rid of the decimal on the outside first. That must be done. There's no two ways around it. But outside of that, it's just long division, except we don't have remainders anymore. We have to keep going. So if we have 4.5 and we're told to divide 4.5 by 0.9. That divided by that, 4.5 divided by 0.9. We can't proceed until we get rid of the decimal on the outside. Whatever we do on the outside, we have to do on the inside. This is actually 45 divided by 9, which of course is 5, because 5 times 9 is 45. That one wasn't even long division once we took care of the decimal. That one was a basic division fact from our multiplication table. What about 3.168 divided by 0.36? We got to take care of that decimal on the outside, 1, 2. Inside, 1, 2. That means that we have 316.8 divided by 36. You say, what about that decimal on the inside? I say, what about it? Is it on the outside? You say, no. I say, exactly. We only care on the outside. Doesn't matter where it falls on the inside, because wherever it does fall, that is the place where we're going to end up putting it right up in the answer. 36 goes into 3 0 times. 36 goes into 31 0 times, so it looks like we're doing 36 goes into 316. How many times? Well, does it go in 9 times? It's got to be a big one. I feel that's got to be big because they both begin with 3, so that's got to be close to 10. 36 times 9 is, carry the 5, 27, 28, 29, 30, 31, 32. Too much. 36 times 8, 48, carry the 4, 24, 28. That fits. 8 times 36 was 288. Subtract. 16 minus 8 is 8. Borrow. 10 minus 8 is 2. Okay. And then bring down the 8. 36 goes into 288. 8 times evenly. So 8.8. This is no more difficult than regular long division. We just got to take care of those decimals first. Remember, it doesn't have to be given like a division problem or like a division problem. It could also look like a division problem. The one that looks like a fraction, which in this weird order that I teach this class in, we don't know what a fraction is yet. We will after the test. So this is a division problem with a top and a bottom. This divided by that. So the bottom is the same as the outside. So if you want to take care of the decimals here, the bottom is the one that you cannot let be a decimal. So we would move it until it becomes not 0.3, not 3.3, but when it becomes 33 with the decimal point at the end. And whatever we do on the outside, 1, 2, 3, we have to do on the inside. So this is actually the same as 1584 over 33. 1584 divided by 33. And let's do it. 3 times 5 is 15, so is it 5? What's 33 times 5? I think it might end up being a little too much. Yeah, that's 165. That's too much. What's 33 times 4? 4 times 3 is 12. Carry the 1. 4 times 3 is 12 plus 1 is 13. So it goes in 4 times. 132. We subtract. We get 26. Bring down the 4. How many times does 33 go into 264 now? Well, what's 33 times 6? I'm just going to keep going. 6 times 3 is 18. Carry the 1. That's a 198. I'm going to keep going. 13 times 7. I'm going to press my luck. 7 times 3 is 21. 23. I'm going to keep going. 33 times 8. I'm going to have to erase something eventually. 8 times 3 is 24. Carry the 2. 264. Hey, it went in evenly, and it was 48. We can check with multiplication if we want to. Division and multiplication have that same sort of relationship that addition and subtraction did in terms of the checking. So if you want to just do 48 times 33 to be safe, 3 times 8 is 24. Carry the 2. 14, 24, and 1584. Okay, I feel better. 48 is the answer. So these division problems can be quick or they can go on a long time. Sometimes it's going to keep going and going. So you might get a direction to round your answer to stop you from having to do too much work. For instance, if we had this one, 495.97 divided by 2.3, and we were given the direction to round to the nearest whole number. So to the ones spot, basically, to the nearest whole number. Decimal on the outside. That we cannot abide. So we move it one spot. 4959.7. 23 goes into 49. By the way, move that decimal place up into the answer. 23 goes into 49 twice. Whoa, got ahead of myself. 23 goes into 49 twice. 2 times 23 will be 46. Subtract, we get a 3. Bring down the 5. 23 goes into 35 once. We subtract. 12. Bring down the 9. 23 goes into 129. Is it 5? 5 times 3 is 15. 10 plus 1 is 11. And then 23 times 6, that one would be too much, right? Yeah, 138. So it goes in 5 times. 5 times 23 is 115. We subtract. We get 14. Bring down the 7. 23 goes into 147 6 times. And guess what? It's okay that I don't have any more room down here because I don't need to do any more work. I have enough information now to round to the nearest whole number because that's the whole number. And looking to the right, That is a 6, which means I round up. And my answer would be 216. Not bad, huh? For our next one, let's go ahead and round to the nearest hundredth. We're going to have 0.432 divided by 0.039. We cannot abide the decimal point on the outside. 1, 2, 3. Inside would go 1, 2, 3. This has become 432 divided by 39. 39 goes into 43 once. Subtract. We get 4. Bring down the 2. 39 goes into 42 once. Subtract. We get 3. We have nothing else to bring down. In the old days, we could say 11 remainder 3, but now we have to round to the nearest hundredth. What the crap is this? It's okay. It's okay. Calm down. We'll be fine. Give ourselves a 0.0 and bring it down. Put that decimal point up top. 39 goes into 30 0 times still. We need another 0 to bring down. 39 goes into 300. That seems like it could be a big number. Is it 9? 9 times 9 is 81. Carry the 8. 27 plus 8, that's 351. That's too much. Too much. Uh, 39 times 8. 2, carry the 7. 24 plus 7. 312. Too much. 39 times 7. 7 times 9 is 63. Carry the 6. 21 plus 6 is 27. That's going to have to be it. Seven times 39 is 273. Subtract. We get 27. Now, we were told to round to the nearest hundredth. We have 10th, we have 100th. We need to know what that next number is in order to finish the rounding. We don't have to keep going on and on forever, or however long this is going to take, because we got this gift of being able to round to the nearest hundredth. We have 27. We bring down one final 0 that's getting cut off up here, but that's 0.000. We bring this final 0 down. Oops, to here. $273 would be too much, so it's going to have to be 6, because this is just too much. But guess what? I don't need to do 39 times 6 because I know it's 6. And that 6 was all I needed. I don't need anything else down here. That's all I needed to tell me to round up to 11.08. rounding works just like it does with whole numbers with decimals. So 5 or above to the right rounds it up. Anything that says round to the nearest hundredth has to at least have a hundredth spot. So if something were to, for instance, round up to 12.0 and we need it to, or 12.00 and we need it to the nearest thousandth, we need to make sure that thousandth spot is in there. So round to the nearest hundredth has to have a hundredth spot. When we're dividing, we have to go one beyond to see if we round up or not. Before we move into order of operations problems, I want to show you a trick. Remember, we had a trick for multiplying by something like 100. If we had 23 times 100, we could do 23 times 1 is itself and add the 2 zeros. So times 1,000 would be a third zero, 23,000. If we multiply a decimal by 10, 100, 1,000, the number of zeros is how many places we can move the decimal point to get the correct answer. So here, 1, 2, 3 zeros means we would take 3.2 and we would move it 1, 2, 3 spaces to the right. And since there's no numbers here, we would fill in zeros. Why do we move it to the right and not the left? Because that turns it from 3 to 32 to 320 to 3,200, 3,200. It's getting bigger as we move to the right, and times 1,000 is making our number bigger. So the answer here would be 3,200 because we just moved the decimal place 1, 2, 3. 1, 2, 3 points to match up with the 3 zeros. If we had 2.917 times 100, that's 2 zeros. That's 1, 2 places to the right, 291.7. Now multiplying by 10 by 100 by 1,000, that makes it bigger. What if we wanted to make it smaller? Do we have a trick for that? What if we move the decimal point in the other way? That makes it smaller. And that's multiplying by 0.1, 0.01, 0.001, 0.0001. So just 1 after all zeros. This makes it small. This makes it smaller. This makes it smaller. This makes it really small. Because what is this? 1/10. Makes it 1/10 as big. Multiplying by 0.01 would make it 1/100th as big. Making it by tenths, hundredths, thousands, 0.001 would be making it 1,000th as big. Way smaller every time. So here we're going to count how many spaces to the right of the decimal. If we had 2.3 times 0.1, we would count this one spot, just like when we multiply normally, one spot, but just here. And that tells us we're making it one place value smaller. So to the left one, this would be, whoops, this would be 0.23. And if we had 3.417 times 0.01, these 1, 2 places would be telling us that we can go 1, 2, fill in a 0 there, 0.03417. It's made it smaller. So that's the trick we have with multiplying by 0.1, 0.01, 0.001, how we do it by moving decimals. Another version of this trick comes when we divide. If we divide by 10, what's division doing? It's making it smaller. So we count the number of zeros and we make it smaller by that same number, 0.23. $379 divided by 10. It's getting smaller, 1 0. 37.9. Let's say we had 461.05 divided by 10,000. That's making it real small. 4 zeros. We're going to make it smaller. 1, 2, 3, 4 places. 0.046105. Okay, finally, order of operations. Remember, please excuse my dear Aunt Sally. We did it a lot. It's not 6 steps. It's 4. Parentheses or any grouping symbols first, then exponents. Multiplication and division from left to right as we come to it. Until that's all gone, then all that's left is addition and subtraction. We'll do that left to right as we come to it. Now we're going to look at problems involving decimals, though. 0.4 times, in parentheses, 8 minus 3.8. So we need to know how to do all these things with decimal, addition, subtraction, multiplication, and division like we did today. Parentheses first. So inside we have 8 minus 3.8. Line up the decimals when we subtract. 0 minus 8 can't be done. Borrow. 10 minus 8 is 2. Decimal point to keep them in line. 7 minus 3 is 4. So that means that we have 0.4 and then times, because that's what parentheses means, times 4.2. We worked inside the parentheses first. That's why we did subtraction first, not because we're breaking the rules, but because the rules say work inside the parentheses using order of operations in there as well. And all we had was this one subtraction problem. And then we multiply. 4.2 times 0.4. 4 times 2 is 8. 4 times 4 is 16. 0 times everything would just be zeros. 2 places past decimal points, 2 places in the answer then. Our answer would be 1.68, which we say how? It ends in the tenths, hundredths spot. So 1 and 68 hundredths. Order of operations, same as last class, only now with more work. I would like to look at this one next. 0.51 plus 4.41 all over 3, and we'll see another one of these later in the review. This fraction bar is division. So we do the top completely, we do the bottom completely, and then we divide as the final step. Bottom's already done for us. It's just the number 3. On top, we add, which means we line up the decimals. decimal point goes in the same spot in the answer. We get 4.92, and that is over 3. That means division. We're all good right off the bat because the outside is not a decimal. So bring the decimal point up and divide. 3 goes into 4 once. 3 goes into 19 6 times. That's 12. 3 goes into 12 4 times evenly. No remainder. 4 times 3 is 12. 12 minus 12 is 0. 1.64 is the answer here. So as long as we're doing our new decimal arithmetic correctly, we can get through any of these problems because we know the steps. Let's look at 7.2 minus 7.83 divided by 2.7 plus 9.6. Well, what do we do first? There's no parentheses. There's no exponents. So we look for multiplication and division from left to right, and ding, 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 there it is. So the first thing we do is going to be 7.83 divided by 2.7, which we're going to make 78.3 divided by 27, because we need to get rid of the decimal on the outside. 27 goes into 78. Will it go in 3 times? 27 times 3, carry the 2, that's 81. No, so only twice. 54. It's 24 left. Bring down the 3. 27 goes into 243 how many times? It looks big. Is it 9? 3, carry the 6. Sure is. 9 times evenly, and because that decimal point was there, 78.3, it goes straight up 2.9. That's not the whole answer, though. All of that was just to get the 2.9 right here. Around the 2.9, we still have 7.2 minus 2.9 and then plus 9.6. No more multiplication or division, addition or subtraction from left to right as we come to it, not addition, then subtraction. That will give you the wrong answer. It does not mean addition first, then subtraction. It means addition and subtraction left to right as we come to it. So next up, this subtraction problem. 7.2 minus 2.9 is 4.3. Plus 9.6 is 13.9.